Hey friends, welcome back to science. And today we are working on the history of the Earth. We've already done lesson 1 and 2, and we've been talking about what the Earth looks like. Globe real quick. Remember our globe, we had the blue was water. On our globe, all the colorful places were the continents, where we live. Find where we live. Here we go. There's North America. We live in the United States. We live right about right here in Tennessee. Remember that the Earth is made up of layers. We were talking about how it's got a crust on the outermost layer, and we had the North Pole and the South Pole, and we're going to dig a little deeper today, and I think we're going to go inside the crust. Okay, so let's just get started. We're going to share our screen so you can see what we're going to do today. Wrong thing. There we go. And present mode. Okay, so let's look at this. This is the Earth Inside Out, part 2, the history of the Earth. Okay, so let's go over our vocabulary words that we have for today. Disaster, events that cause much destruction. Technology has made it easier for scientists to predict natural disasters such as earthquakes. Now, natural disasters that we've seen around here would include we've seen some tornadoes. We've had some really, really bad like thunderstorms before. We've had flooding before. We've seen fires and things like that. So those are natural disasters that we see around here. But hurricanes are also natural disasters, and volcanoes, things like that. Liquid, moving or flowing freely. Liquid rock deep inside the earth. Molten, made liquid by heat. It takes very temperatures to melt metals into molten forms. Solid, keeps its shape. They put the water in the freezer so it becomes solid ice. Volcano, a mountain formed by the ejection of lava, gases, and ash from an opening in the Earth's crust. I could see the volcano erupting from space. All right, friends, let's get started. Using the diagram that we see here on the thing, let's name the layers of the Earth, okay? Let's see if we can do this. We have the crust, little tiny thin layer. We have the mantle, big, thick, orangish, reddish looking part. We have the outer core, that's the more orangey one. And then we have the inner core, okay? We live on the crust, that little tiny thin piece right here, that's where we live. The crust, where geologists look to learn about the history of the Earth. Many layers of rocks found in the crust can teach us about different periods of time in Earth's history. We're to chant and clap 3 times the important words that Gary the geologist said to remember when studying geology. Are you ready? Heat, pressure, time. Let's do it again. Heat, pressure, time. One more time. Heat, pressure, time. Nice job. Heat, pressure, and time are important because they cause many changes in the Earth. Okay, so all the things in Earth can be described as being a solid, liquid, or a gas. If something is a solid, it keeps its shape. So like this, solid. My cup is a solid, okay? Doesn't change shapes at all. I've lost my spot. If it's a liquid, it can be poured. Now, I have a liquid in here. I'm not going to pour it out because that would make a big, big mess. It doesn't keep its shape, but it takes the shape of whatever it's in. So if I were to pour this out into something different, it would take that shape. So right now, it's in the shape of my cup. Let's see. All right, now if something is a gas, it's often hard to see. So if you take a deep breath, you're breathing in a gas. Oxygen is a form of a gas, okay? It's not solid, so it doesn't hurt us, and it's not liquid because it can't be poured. It's not solid because it's not hard, doesn't keep a shape. So we have all kinds of different forms of gas. You ever see steam rise up? That's a form of gas. All right, so heat can change things from solids to liquids to gases. So if I have an ice cube, that's a solid. It's a form of water, okay? When I heat it up, the ice cube melts and becomes water. When I boil that water, then it becomes a steam or a vapor, which is a gas. So today we're going to hear about all the solids and liquids inside the earth. So listen carefully so we can hear more from Gary the geologist about other layers of the earth, the mantle and core. You ready? Oops, sorry. All right. Today, we are going to pretend that we can journey deep, deep into the earth, all the way to the very center, 4,000 miles from where you're sitting right now. Remember, this is the center right here. The first stop is the layer beneath the crust. There's that layer. We were talking about it. What was it called? The mantle. The mantle is a whopping 1,800 miles thick and contains most of the Earth's rocks. Whew. Now, if you were to go, and I don't think you can see it very well, but if you were to travel from New York all the way, let me find it. Can't find it. Here it is, all the way to Colorado. So from here to here, that is 1,800 miles. Okay, that's how far, and it doesn't look that very far from on our globe, but it's a long, long way. It might take us like almost 3 days to drive that, or maybe 2 days to drive that. That's a long way down. So from where we live on the crust down into the mantle, it is that thick. That's pretty thick. Because most of the earth is made up of rock, that means that most of the earth is contained within the mantle. The mantle is mostly made of solid rock. The closer to the crust, the cooler or harder the mantle tends to be. But as you go deeper, closer to the core, the mantle gets hotter and becomes soft and gooey. Heat closer to the core causes the rock inside the mantle to move around quite a bit. But most places, it is still solid rather than liquid. Okay, did you hear the word heat? Heard the word heat. Remember, heat causes parts of the mantle to move around, and it's solid keeps their shape while liquid moves around and can be poured. So we're heating up a solid to make it into a liquid. The mantle surrounds the core or center of the earth. The core has two parts, the inner core and the outer core. The inner core is a solid metal ball. Remember, here's your inner core. Okay. The outer core is also metal, but it is not solid. It's made up of melted or molten metal. Molten is heat that's changed from a solid to a liquid. This means that deep down inside the earth, thousands of miles beneath your feet, there's a giant sea of red hot molten metal surrounding a soft metal ball. Ooh, that's crazy. Scientists believe that the very center of the earth, the inner core, is actually hotter than the surface of the sun, which is a blazing 10,000 degrees Fahrenheit. Now, if you think about it, in the summertime, the hottest we usually get is kind of in the 90s. Sometimes we get into 100, not very often. So if you think about it, if we got to 100 degrees, that's really hot for us. Could you imagine if it's 10,000 degrees? We would not be alive. We'd be melted. The inner core is much hotter than the outer core. It may seem strange, therefore, that the outer core of the earth is molten metal, yet the inner core at the very center of the earth, where it is the hottest, is a solid ball of metal, which, by the way, is just a bit smaller than the moon. So this inner core right here is just a little bit smaller than our moon up in the sky. It's kind of crazy. The reason that the inner core is a solid has to do with the incredible pressure of the Earth's entire weight pressing inward. The more pressure you put on something, the more heat you need to cause that thing to boil or melt. This is why the metal at the very center of the Earth, the inner core, is solid instead of liquid. Despite the intense heat, there is simply too much pressure caused by weight of the rest of the Earth. So the center of the Earth cannot melt and it remains a solid. Did you hear that word pressure? I've heard heat and I've heard pressure. That's two of our words. So pressure causes the inner core to be a solid rather than a liquid. Okay, so we've heard heat, pressure. We've got one more thing. I wonder if we'll hear that one too. The crust upon which we live is constantly being changed and reshaped due to heat and pressure caused by activity in the Earth's mantle and core. The San Bernardino Mountains that you see in this picture, along with many other mountains along the west coast of the United States, from Mexico to Alaska, were created by changes inside the Earth. Remember, the parts of the mantle that are closest to the core are soft and gooey. That hot, gooey material in the mantle does not always stay in the mantle. Sometimes it rises up to the surface. Every so often, some of that extremely hot molten rock or magma pushes up through the mantle and forces its way into cracks and crevices in the crust. Over time, the magma collects in a magma chamber, such as the one near the bottom of the picture. So here's your magma chamber down here. The heat in the magma chamber releases gas from the magma, which builds up and creates pressure. The pressure builds and builds until one day, boom! Did you hear the word heat and pressure again? I'm hearing it. Heat and pressure cause volcanoes to erupt. The magma erupts in a volcano of lava, ash, gas, and fire. Once it is released from the Earth, the magma becomes lava, flowing liquid rock, which flows across the ground until it cools and hardens into rock once again. So the eruption of lava, ash, gas, and fire forms a mountain called a volcano. So over time, whatever's coming out hardens and it becomes bigger and bigger. Oh, look at that volcano. That's a pretty awesome looking volcano, huh? See, this is where the lava has hardened and become taller. And here's some lava coming down. You can see it all the way down there. All right, now that I've told you about volcanoes, let me explain one more thing. Thanks to geologists, we have a pretty good idea when and where the geologic events are likely to occur. Geologists help predict where volcanoes are most likely to occur, and this helps keep people safe by discouraging them from building homes close to dangerous areas. It's not always possible to predict when and where geologic disasters will occur, but geologists work hard to give people as much warning as we can. So remember, disasters are sudden events that cause lots of damage. And we talked about like tornadoes and hurricanes and stuff like that at the beginning. Now, volcanoes, we don't have volcanoes near us because we're kind of inside the United States, so there's not very many near us. But Hawaii is pretty much built with volcanoes. And actually, they had a volcano erupt, I think about 2 or 3 weeks ago. So it wasn't long ago that they actually have one. And they do have volcanoes that are constantly spilling lava into the ocean. So it's pretty neat. My son and I actually got on YouTube and looked at a video of lava flowing into the ocean. It was pretty cool. All right, guys, now it's time for us to talk about what we read today, what we learned today. So let's talk about our question, shall we? What are the names of the layers of the Earth? We talked about that at the very, very beginning. Ready? We have the crust, the mantle, the outer core, and the inner core. There's 4 different layers: crust, mantle, inner core, and outer core, or outer core and inner core. All right, describe the mantle. The outer core of the Earth is melted or molten liquid. Oh, I'm sorry, I read the wrong one. My bad. The mantle contains most of the Earth's rocks. It gets hotter and softer closer to the core. Now, if I were to describe the outer core, which I was doing, that's the one that's melted or molten liquid metal. All right, Why is the inner core solid rather than liquid? Inner core is solid rather than liquid because of pressure from the weight of the rest of the Earth. Now, how would you describe the inner core? It's a solid metal ball. What causes a volcano to form? Hot molten rock or magma inside the Earth makes its way to the surface of the Earth and causes a volcano to form. Why is it important for scientists to study volcanoes and keep people informed about them? So they can learn more about them and keep people safe from geological disasters. All right, guys, that is all we have for today's lesson. So now it's your turn to do your job, which is to go into Google Classroom and answer the questions that go along with today's lesson, okay? And we've already discussed all the questions because I just asked them to you. If you don't remember, you can always go back and listen to the video again and see if it can help you out. All right, guys, see you tomorrow. Bye.